For question 9, A. If bracket open p plus 1 bracket close x squared plus 4px plus bracket open 2p plus 3 bracket close being equal to 0 has equal roots, find the integral value of p. And for the B, you have to solve for x and y in the equations log bracket open x minus 1 bracket close to the base 10 plus 2 log y to the base 10 is equal to 2 log 3 to the base 10 and log x to the base 10 plus log y to the base 10 is equal to log 6 to the base 10. This was the question 9 in the Wassce 2020, the elective math theory paper. So we'll try going through the solutions for this particular question. Now let's start with the A. For the A, you have been given an equation. This is in the form of quadratic equation. And the question is saying that if this quadratic equation has equal roots, you should find the integral value of p. All that they mean by the integral value of p is to find the positive value of p. So definitely the value that you are going to get, the positive value that you will get, that is what we are interested in. So that is what they mean by you finding the integral value of p. So as it stands like this, the equation, you have bracket open p plus 1 x squared plus 4 px plus 2p plus 3, and this is equal to 0. And if you are saying that a quadratic equation has equal roots, then it means that the discriminant of that quadratic equation is equal to 0. Now the discriminant is the b squared minus 4ac. This is the discriminant. So the question is saying that that quadratic equation has equal roots, then it means that this discriminant, the b squared minus 4ac, is equal to 0, where the a, b, and c, they are constants in the quadratic equation. Now in this case, we need to get the value for the b, the a, and the c. We have to get the value of what they represent from the quadratic equation. So what we are going to do is we are going to compare this particular quadratic equation. We are going to compare that to the general quadratic equation. Okay. So we have the p plus 1 x squared plus 4px plus 2p plus 3 is equal to 0. We are going to compare this to the general quadratic equation, that is the a x squared plus bx plus c, and this is equal to 0. Now the a is representing the coefficient of x squared in the general quadratic equation. So by comparing, the a corresponds to the p plus 1. When it comes to the middle term, that is the bx, the coefficient of x is the b. So in this case, it corresponds to the 4p because the equation up there, the coefficient of x there is the 4p. And then lastly, the c, which is the constant here, also corresponds to whatever that is left there. And that is the 2p plus 3. So in this case, our a is equal to p plus 1. Our b is equal to the 4p. Our c is equal to 2p plus 3. And we said for the equation to have equal roots, then the discriminant, that is the b squared minus 4ac, is supposed to be equal to 0. So we are going to substitute what the a, the b, and c represent. We are going to substitute them into this particular equation. So we are going to have our b squared, and that is the 4p squared, and it's 4. Our a is what? P plus 1. Multiplying c, and our c is what? 2p plus 3. Therefore, this is equal to 0. So we try simplifying or expanding the bracket in there, then we solve for the unknown variable there, and that is p. So 4p squared, that is 4p times 4p, and this is going to give us what? 16p squared. So minus 4, we hold on to the 4, then we expand these two terms. So p times 2p is going to give us 2p squared. The same p times 3 is going to give us 3p. 1 times 2p is going to give us 2p. Then 1 times 3 is going to give us plus 3. And it's equal to 0. So we're going to have our 16p squared. We use the minus 4 to multiply everything in the bracket. So this is going to give us, and it's 8p squared. The same minus 4 times 3p is going to give us minus 12p. The same minus p multiplies the 2p, and this is going to give us minus 8p. The same minus 4 once again multiplies the positive 3, and that will give us minus 12, and that is equal to 0. So there are like terms there. We try and simplify that. 16p squared minus 8p squared is going to give us 8p squared. Minus 12p minus 8p is going to give us minus 20p. So minus 12 is equal to 0. Now the equation that we are having here is quadratic equation. So we need to solve this equation. We need to solve and get our two values for p, or because the equation is quadratic. Now as it stands like this, yes, we can use any of the methods for solving quadratic equation, either the factorization method, the completing of squares method, or the general quadratic formula. Here I want to use the factorization method, but as it stands like this, the equation can be reduced. There is a common factor throughout the term there, so we can reduce that by dividing through by this common factor, or we can maintain it just like that, and then we solve the equation. Now there is a common factor, and that common factor is 4. So we can divide this by 4. We divide this by 4. We divide this by 4. We divide this by 4. In fact, this is not going to change the actual value of p. No, if you maintain the equation as it is like that, then you solve, you get the same answer. Okay, so now this 4 goes into the 8. We have 2. Once again, this 4 2 goes into this 20. We have 5. Then this 4 goes into this minus 12. We get 3 here. And then 0 over 4 will give us 0. So we are going to have 2p squared minus 5p minus 3 is equal to 0. So the normal factorization method, minus 3 multiplies the 2, and that will give us minus 6. You find two numbers in which when you multiply you get minus 6, but when you add you get minus 5. That is the coefficient of p, and that is minus 6 and a positive 1. Okay, so we are going to have our 2p squared minus 6p plus 1p minus 3 is equal to 0. Take the first two terms, we factorize, then we take the next two terms, then we factorize. So the first two terms, the common factor there is 2p. That comes out, we are going to the left with p minus 3. Close the bracket, take the next two. Common factor there, in this case, positive 1. You open your bracket and you are going to be left with p minus 3 equal to 0. Therefore, you are going to have your p minus 3 and 2p plus 1 all being equal to 0. We are solving for p. Now we have two linear factors multiplying, and that is equal to 0. So what we are going to do is we take each linear factor and then we equate that to 0. So we are going to have our p minus 3 being equal to 0. Solve for p. Now p will be equal to 3. We take the other linear factor, that is a 2p plus 1 is equal to 0. And this will give us 2p being equal to negative 1. Divide both sides by 2 and we get our p to be equal to negative 1 over 2. Therefore, we have two values. P is equal to 3 and then p is equal to negative 1 over 2. Therefore, the integral value, that is the positive value, and that is going to be the 3. Therefore, the integral value of p is 3. So that is the A part of question 9. Okay, for 9b, you have to solve for x and y in the equations there. Now these are logarithmic equations, so for us to solve the equations there, we need to apply some of the laws of logarithm to simplify this further. Okay, so the first equation there, we have log x minus 1 to the base 10. Now the base was not given, so we assume that the base is 10. Okay, so if you look at this side, we have two terms there. We can combine them to get one term there. Alright, so this is going to give us, we have log, since the two logs, as in this particular logarithm and this particular log, since they are adding, it means that if you want to combine them to get one log, the numbers here, this x plus x minus 1, sorry, and then what you are having here, that is you will be having y squared the two logarithms, they are going to multiply. So we are going to have log x minus 1 plus log y squared. We try applying the exponent law. These two, that is here, should be moved so that it serves as an exponent for this y. The same thing applies to this 2, should be moved so that it will be an exponent for this 3. So this will be equal to log 3 exponent 2. Therefore, combining them, we are going to have log, so you'll be having this particular number times this particular number here. Alright, so you'll be having x minus 1 times y squared, and this is equal to log 9. Now we can try taking antilog of this, but there's a property that if you have log a being equal to log b, if that is the case, then a is equal to b. So in this case, we have log an expression is equal to log of a number. Therefore, what you are having here will be equal to what you are having here. Therefore, we will be having x minus 1 y squared being equal to 9. So this can give us one equation. We can label that as equation 1. We come and pick the second logarithm equation here, and then we try simplifying that one too further. Okay, so that is going to give us log x plus log y. This will be equal to log 6. So combining the two will give us log, we have x, y, the x and y, they are going to multiply. This x and this y, they are going to multiply because the sign between them was addition. So log xy will be equal to log 6. If that is the case, then xy will be equal to 6. If you try finding the antilog of that, or going by that property, that if you have log a being equal to log b, then a is equal to b. So that is what we are using here. Therefore, we are going to have xy being equal to 6. We can label this one too as another equation. So let's say equation 2. Now the two equations, let's rewrite them again and see how we can solve for x and y. So we have the first equation to be x minus 1 y squared being equal to 9. This was the first equation. And then we have the second equation to be xy being equal to 6. Now we have to solve equation 1 and equation 2 simultaneously. And how can we do that? We try taking one of the equations and make a variable the subject in there. So let's consider equation 2 and make a variable of our choice the subject in there. So from equation 2, making x the subject, so we want to make x the subject from equation 2. If that is the case, then from x, y being equal to 6, we can divide both sides by y, both sides by y. And we are going to have our x to be equal to 6 over y. So we can label this as equation 3. Therefore, what we can do is we can substitute this particular equation into equation 1. So putting equation 3 into equation 1. In equation 1, we were having x minus 1 y squared being equal to 9. So where we are having x, let's substitute the y minus 6 there. So we are going to have, so this x is going to be the 6 over y minus 1 being multiplied by y squared, and that is equal to 9. This y squared is going to multiply each term in the bracket. So you're going to have y over 6 times the y squared minus, you have 1 times y squared. Y will cancel one of the y there, so you are going to have 6y minus y squared. So we have equal to 9 here. So this will be equal to 9. Now what we are having here is quadratic equation. So you rearrange that in that order. Therefore, we can decide to shift the minus y squared to the other side because we want it to be positive. Therefore, this minus y squared, when it crosses the equal sign to this side, it becomes positive. And then the 6y also, when it comes to this side, becomes negative. Therefore, we are going to have 0 being equal to, we have y squared minus 6y plus 9. Because already the 9 here was positive. So we can rewrite this equation, and this is the same as you having y squared minus 6y plus 9 is equal to 0. So as it stands like this, we have to solve for y, either by using the factorization method, or the completing of squares, or the general quadratic formula. So this, we can use the general quadratic formula or the factorization method. Okay, so this will give us y squared minus 3y minus 3y plus 9, and this equals to 0. We take the first two terms, we factorize, we take the next two terms, we factorize. So we are going to have y, bracket open, y minus 3. Once again, the common number is minus 3, so minus 3 comes out, you have your y minus 3. It's going to be minus 3, not positive 3. Most students would think that this side is going to be positive 3. This is equal to 0. So this will give us y minus 3, y minus 3 is equal to 0. Now, as it stands like this, you take each factor, you equate it to 0, and you solve for y. You get the same value for y because you have y minus 3 here, y minus 3 here. So, we're going to have y minus 3 being equal to 0, y minus 3 being equal to 0. Therefore, y is equal to 3. Just pick one. If y is equal to 3, then what is its corresponding x value? We need to find that. So we can substitute y being equal to 3 into equation 3, and that one will give us the corresponding value of x. So putting y being equal to 3 into equation 3. Equation 3, we are having x being equal to 6 over y. Therefore, x is equal to 6 over y, which is what? 3. Therefore, our x is equal to 2. And x is equal to 2 and y is equal to 3. So this brings us to the end of equation 9 of the elective maths paper of the Wassce 2020.